Hello everyone. My name is Xinqiu Shi, and my direction is reinforcement learning. And then I will introduce my study progress. First is online courses. Last month, I have finished the last three lectures which taught by David Silver. This means I have finished the theoretical part of the online courses. And the second part is deep learning. I have learned some theoretical knowledge of neural networks and also some functions of TensorFlow. Although I haven't finished all of them, but I can build a neural network and use it into my Hisense Rack now. And here is the link of online courses. Next, I will introduce the algorithm. Here is a picture of almost all basic algorithms of reinforcement learning. And last month, I concentrate on here DeepQ network and policy gradient. DeepQ network is based on Q-learning algorithm, and here we use neural network to approximate the Q-value function. Well, here the DeepQ network. Here I use very classical.
Sorry, and also policy function, right? Not only a Q function, policy as well, right?
You mean?
We approximate value function and policy function.
Value function.
Could you please repeat? Could you please repeat in DQN what do we approximate using deep neural networks?
Approximate the Q value is a value function.
Okay.
Not policy. If we both use them together, it's A3C, I think.
Okay.
Yes. And here I use the very classical environment. In gym, it's mountain car. And we have a car here, and for our state, there are two dimensions, position and velocities. And here we can see the state space is continuous. And there are also three actions, push the car to the left, right, and no push. And for the reward, at each step, the car gets reward -1 until it can reach to this flag, the turning point, or after 200 steps, if the car cannot reach the flag, then the game also over. Here we can see the logs of DQ TensorFlow. Here I will use Tensor. It's very similar with the first traditional machine learning, and we got simple here. We got simple here, and we put it into the neural network. And our simple is from the experience that our agent it's from the experience. And what we put to the neural network is we also call it transition SARS. State action reward state is also called transition. And we use this as input and put it into the neural network. And then we can get our output is Q value. We can see from here we got two neural networks. One is evaluation network, and another is target network. For this one, we output Q evaluate, and for this one we got Q target. And here we got loss function which equals to Q target minus Q evaluate. And we can use back propagation and put this value in. We use the back propagation, and then we can update the parameters in evaluate networks. And here, these two neural networks, their structure is the same, but for the parameters, for example, at the 0 step, the evaluate network, the update, this network update its parameters, but for target network, it fixed its parameters. So we can get different value from these two, and we can use back propagation to update the parameters. And after maybe 1,000 steps, target network, evaluate network will assign its parameters to target network. And when the loss function converges, this value converges, we can get the Q optimal value. And next, here are some results of DQN. Here, the first, the x-axis is the number of episode, and the y-axis is the reward. We can see from here, after maybe 50 episodes, the car can reach to the final point, and then this after thousands of episodes, this function converged. So I didn't plot them all. And here I also plot a picture of here is state and action pair, and here is the Q maximum value for all state action pairs. And then I will introduce some modified DQN.
Wait. Sorry, one short question.
Okay.
You explained how you train, how you build the neural network for Q value, right?
Yes.
But you never explained how you use this Q network. That's the most important part, right? So DQN is based on the Bellman equation, dynamic programming, right? What is Q value, how it is connected to policy, how to use it? It's the key point, right? But how to use it? A little bit wider. Just could you say a few words?
Sorry, you mean the MDP formula I should explain?
Maybe, but at least by words you could.
Yes, here is
okay.
I use
okay.
Yeah, I use the formula of Q target to explain double DQN here.
Okay, no problem. Okay, then you
Is I can continue.
Mm-hmm.
And for WDQN, I use a new environment which is a pendulum. Here we got a stick, and our state is the 3 dimensions, the cosine theta of the angle, and sine theta, and the theta dot, which is also called the angular velocity. It's the speed of this stick, you can see. And our action is only one. I can see it's a force that if it's a force that we can push the stick. If the stick stands, then we can get the reward, and here is the reward function. And here you can see is the formula of Q target of DQN and double DQN. Here we used dynamic programming, and RT is the reward of the RT is the reward of the you can see of the Q null. You can see Q value null, and here is the maximize the Q value for the next stage, and you can see the difference between these two is this action. here on a different. Here, actually, we use the parameters of Q target of this network. And here we use the parameters of the Q evaluate network. Or I can explain it with the with the graph here. Because in neural network in neural DQN we predict the maximize the Q value by this neural network, but there is an error that at each step we update the parameters of evaluate network with the maximize the error of Qt minus Q target minus Q evaluate, and this will cause overestimating for DQN, and for double, which means the Q target value, this value will be bigger than its real value, and to avoid this, here for Q target we use the action which calculated by the Q evaluate, and which means we calculate the Q target with two kind of parameters. The parameters of target networks and the parameters of evaluate networks. And here is the result for the environment. We can see from here. The x-axis is training steps, and the y-axis is Q evaluate. The Q value here for natural network is bigger than its Q in double DQN. This is overestimate, which is Q target in natural DQN is always bigger than is in double DQN. And another modified DQN method is dueling DQN. And this what is different from this from the natural DQN is here. We can see from here the structure of the neural network is totally the same, but what is different is in the neural network. In dueling DQN, we divided the Q function to two parts. The first part is the Q value of state, which depend only on the state, and another is this which we call the advantage function. This is Q value depend on the action from a particular state, and this this depends on only state S, and this depends on S and action here. And this is different, and what this will affect the result. We also use pendulum environment here, and you can see from the result of the first picture. The x-axis is the training steps, and the y-axis is the loss function. We can see it's converges almost at the same time, but at the end, when the dueling DQ, when the loss function of dueling DQN is converged, but the loss function of natural DQN is also a little shifted. But if maybe it's not obvious, but if we see another picture here, the x-axis is training steps and the y-axis is the cumulative reward. You can see when the cumulative reward is curved of dueling DQN, and the cumulative reward is also still go minus of natural DQN, which means the natural DQN is not stable when it's converged. and the dueling DQN is more robustness. We can say like this. Also, there is a third modified DQN model. Its DQN is parallelized experience replay. I can explain this also with this picture here. In natural DQN, we also have experience replay, but for all the transition in history, we look the same. But in parallelized replay, how to say? Yes, we calculate for the transition, which with more, which for transitions which this loss function is bigger, then we will parallelize it, which means if this loss function is bigger than our I can say like that, if this loss function is bigger, then the model can learn more from this sample. So we parallelize this sample, and which means we can learn faster than the previous natural DQN. And here we also can see the results. Here, the x-axis is the number of episodes, and the y-axis is the total training time. When the time is the same, then the DQN with the parallelized replay, it have trained 10 episodes, but for the natural DQN, it just have trained 5. Parallelized replay DQN, it converged more faster than the natural DQN. And that's the end on this paper I have read last month. And for further plan, for the next stage, because I have finished the theoretical part of the online courses, so I will concentrate more on my PhD project and on more higher algorithm DDPG and A3C here. And this is my further plans next month. And that's all. Thank you.
Thank you very much, Sun-Sushi. That was very great. I'm very happy for you. Actually, you're doing very fast. So you're not only preparing a theoretical part, but also you were involved in some project work. Maybe for now it's a little bit slow, but I hope that this time we already kind of understood the problem, understood how we can work with it, and so on. Thank you very much. That was very great. I have a few comments. So, for example, well, I could understand almost everything that you have presented, but actually not all people can have still have the same kind of level of understanding of the reinforcement learning, and not only reinforcement learning, but also some control theory, so dynamic programming. So maybe they could not capture all. But as I said, you are kind of a tech leader for the group that works in the direction for the reinforcement learning. So your presentation is not only to show to me, but to share with others some understanding, some results, and so that they could look and ask you some questions, get some motivation, get some understanding, and then you could work together. This is the key point. You should work all together. And for example, when you introduced a specific problem, I forgot the problem with the car, right?
Yes.
You introduced the algorithm, you introduced some parameters, but you did not introduce what we need. Or the question with in Russian it's called maятник. I don't know. You understand what I mean? This thing. I forgot
Yes.
the Yeah, what is the name in English with this? Uh, do you understand what I mean? That thing that you need to stabilize.
Stabilize.
Can you show the second example? I remember you had the second example, environment or second environment. Can you show it to us?
The second, okay.
Second, yeah. Yeah, pendulum. Maybe it's pendulum. I don't remember. Sorry.
Oh,
it's
this.
just I don't. Yeah. This. You never introduced what we should do. We should stabilize it, right?
Yes, to make it stand.
Stand like this,
Yes.
not be here, but stand, right? And
Yes.
it's a kind of this kind of problem comes from the classical problem of optimal control theory,
Yes.
where you need to know how to control this thing so that it will not, under some random perturbation, will not go down. So you should explain this in the beginning. No need too much words, but some introduction, because not all people can understand the key point of this. Yeah, so what you're doing here is you're replacing the optimal control theory. You know, optimal control theory is a very vast direction. It's applied to control rockets, spaceships, applied to chemical engineering, to a lot of things. But what is reinforcement learning doing now? It's replacing it. Because it's more adaptive. Reinforcement learning can be, it's a basis for artificial intelligence, and it can. The key point of reinforcement learning is to, the goal is to make algorithm that can solve any kind of problem.
Yes,
you
just need to know the environment.
Yeah. So in control theory, you need to know, and you build a very good controller, optimal. But here you just can say to reinforcement learning algorithm or AI intellectual, you can say, please stabilize pendulum, and then you say, okay, I will train myself, then I will stabilize. So that's very important, very, very important. So all these examples are very important to understand. Okay. So actually, so you're doing great job. Thank you very much, and I hope next time you can say a few words about this.
Yes, I should prepare more about the presentation or English, I think.
Yeah, no problem. You are doing great work, and it's good to share this work with others.
Yes, I made the PPT, but I didn't have a review. But I think this is proper.
No problem. No. It's not a big. We just, it's a kind of communication. So and it's the same for everyone. You should, for the regression model, for example, no one introduced why we need regression. Why? We use regression all the time, but why we need it's you do not need to spend too much time for it. Okay, I will not take much of your time. Thank you very much.
Okay.
Thank you.
Thank you. Happy birthday, Professor.
Oh, thank you. It's a working day, not a happy birthday. Thank you.
Hello, thank you, Sun Qiushi. His presentation is perfect, and because we have less time, the following students, if you speech your presentation, maybe you can faster and shorter. Thank you. Next student is Li Qiong. Li Qiong. Okay, thank you.
We cannot hear you.
说话了吗？我没听见你说话。 Yiqiu?
We
Yiqiu?
cannot hear you. We cannot hear you.
Yiqiu?
现在能听到了吗
OK
？Hello。OK。And hello everyone, I'm Li Chong. In last week, I learned about
Please zoom in. Zoom in. Zoom in.
sorry, what?
把你的放大放成全屏。
Okay. Last week I learned online courses about TensorFlow and policy gradient and actor critique, and I do some Python practice about this. And
Sorry.
Mm.
What kind of practice? What percentage of online course have you finished? What you plan to do next month? Please be more specific. As in previous presentation, can you say, estimate? No need very precise. Estimate, okay? How much percentage? How much video have you watched, or how much books have you?
This online course I learned about 19%. It will be quickly finished.
But you also do Python, also 90% Python home task you already finished, or also finished or not?
Practice I do there are two courses I have not practiced it, but the last course I do the Python practice.
Okay. Next time you can put it on the slide so that we directly can read, okay? I hope next month you can do it, okay?
Okay.
Okay, thank you.
And there is about my understanding of TensorFlow. Maybe I read this is very boring. I can show you a simple example. It's a very simple example. To make the red light to to finish the blue randomly point. Hello?
Hello, we can see. It's a kind of a regression model, right? What do you run? Can you explain the red line? Because if it's a regression,
the blue is a randomly generated point, and the line is the red line is approximate about this blue point.
okay. Actually, so red line is a kind of a regression function, right? But you see, I want to show it to you. How to show? Okay, I cannot annotate. So, in the middle of the red line, you have this kind of form, this shape, but this shape is not
Oh.
correct. It means that you have some kind of overfitting.
Oh yeah.
Overfit. Yeah, this is not very correct line. So it means that maybe you need to have used less parameters for the regression function. So because it's a kind of regression with changing trend, or it's kind of polynomial regression. It's not like it's not correct, not entirely correct. But we understand what you mean. You just wanted to present, so it's very good. Thank you very much. Thank you. You can
Okay.
continue, please. You do not have much time, actually. Maybe 5 minutes
okay.
left.
And oh, sorry. And next, I learned about policy gradient. I learned some basic knowledge about it, like approximation of value function, in instrumental method, gradient descent and linear function approximate, future vectors, batch method, and some basic theory of policy gradient. Finite difference policy gradient theorem, and Monte Carlo policy gradient. And that is my understanding about policy gradient. And I also learned some about actor critic is a take a critic to learn about this about reward and pushment mechanism. After learning, the actor will tell you what to do, which is good and which is bad. According to the relationship between learning environment and reward, critical can see the potential reward in the current state. So using it to point the actor can make the actor update every step. And
Sorry. Sorry. I suggest next time for the presentation, and it's a comment to everyone. Do not add text to the slide. This kind of text is it's hard to read. At least use bullet points, like first bullet point, second bullet point, key point, only key point, items. You know what I mean? Items,
okay.
bullet. No need this. It's impossible to read because we need to do two things: read and listen. We can read a book or we can listen, but when PPT, you need easy way for the communication, to use easy way. Okay, please continue, but you do not have much time, maybe 2 minutes.
Oh yeah, that's all. That's finished. That's all my I learned in last week, and I plan to finish the online course. And I plan to do some simple maybe generation about reinforcement learning.
Sorry, I don't understand. What do you mean?
Last month I planned to do some simple general about reinforcement.
Sorry.
Simple programming.
Of course, I hope that when you study online course, you also develop some program in Python. Not only watching videos, right? That's what you do.
Yeah.
So actually about your future direction, I will at some point in time, maybe in 2 weeks, I will send you a papers, maybe one paper for two persons, or maybe one paper to one person, so that you could understand what is your direction and the topic of your thesis. So I will already give you the direction, and I will already start with you working on this direction. So next month, when you, and if only if you finish online course and you have, you think that you have enough understanding and practical Python skills to continue, then I will, maybe next month you can at least use 1 or 2 slides to introduce the topic of your thesis and the model that you want to do and want to use, some ideas, and that is for everyone. That is true for everyone. So if you finish your educational part, such as finish your overview, finish the online course, then I will give you the paper, and next month of presentation you can add 1 or 2 slides, better to introduce your research topic, your direction, what you plan to do, very shortly. And this will be our kind of point for the discussion, and then you could present some results. But anyway, I suggest next time, after you finish policy gradient, actor critic, add some pictures about it, how you, what, as in the presentation of Sun Tzu, he presented several models, several environments, and he added some basic information about it. Then because now I understand that he understands, right? And I should do the same with you. So I should understand whether you understand. Okay?
Okay.
So we will work like this. Also, I suggest you to start using Colab, and the same for everyone. So why Colab? So please search what I mean, because we are a team and we need to develop together. Of course, GitHub and other stuff for the teamwork is good, but I suggest to use Colab, because I suggest you together in one team, or maybe 1 or 2 people, to work on one specific direction and task, and so that you could work on it together in Colab.
Okay.
Right? So because if you do not have Colab, then you need to tune, and you need to set up the environment on each of your personal PC, and that's very hard. That's very hard, and very hard to do some joint work. Yeah.
Yeah.
So in future we'll all focus on Colab, I think, if we will not find any other better solution. Okay, thank you very much, CC. I hope you understand my comments and you remember them.
Okay,
thank you very much.
thank you.
Thank you. You're doing great work. Thank you.
Okay, thank you. So please, next student, Li Juping, and I wish you can do your presentation faster. Li Juping.
We hope we have only 10 minutes for each person, means maybe 7 minutes for the presentation. I use timer, so please hurry up.
可以讲一些重点内容，然后呢，时间可以压缩的快一点点。
Okay, can everyone can see it?
然后声音高一点，离麦克风近一点哈。
Okay. Hello everyone. Can anyone can see it? Hello everyone. Can you see it? My topic is visual data analysis in Python. Visual data and dataset, unit visual analysis, decision trees, decision application model in neural network. I study the open machine learning course molecularly 3 topics in 1 month, and the next month I will study 4 topics. Visual data analysis in Python.
Sorry.
Okay.
Could you say how much percentage when you finish? We need to understand what is your current status now with online course. What is the percentage of video have you watched, and what is the percentage of Python code and homework in Python have you finished? Do you have any questions like this? Because okay, it's the same comment for everyone. Okay.
Sorry, I don't understand. Can anyone help me?
Sun Tzushi, are you
我的
there?
意思，I can。
Okay.
导师的意思是让你告诉一下他你现在到底完成了多少个百分比，就是说你一共有多少 topic， 你完成了多少个 topic， 然后你快速给老师说一下你到底完成了%多少。
Okay, thank you. This have 10 topics and I have studied 4 topics. 30%. Can you hear it?
It's reinforcement learning. What kind of direction? Which direction? It's reinforcement learning, right?
Yes.
那你是不是强化学习的课程？
What kind of online course?
This
Please?
have just in this course we have 10 course and now I have studied 4 topics and
Okay.
in next month I will study 4 topics.
Okay. But your direction is reinforcement learning. True or not true? Which
老师问你的
direction?
他问你的方向是什么？是不是强化学习？
Yes.
Okay. So you plan. So a first slide all the time. Please add what kind of online course do you study? And what is your direction? Because I was not clear what is your maybe you work on XAI. Because I don't know. Okay. And right, yeah.
I study the class you send us.
Okay. But you should give me the information so that I understand what is your direction. Your direction is reinforcement learning. So the title should be reinforcement learning. You should write down this slide. How many what is the percentage? For example, if you study 2 online courses, you plan to study 2 online courses, you can write down open machine learning courses, 30% finished, and Python and video,
Okay.
and then okay.
Next,
And then
I will write it.
Then reinforcement learning courses. I have finished maybe 0% now, but I plan. Okay, then I can understand what is your progress. It's not bad. It's good, but I should understand what you do. Okay.
Okay, hello. Next time I will write it.
Okay. Thank you. Please continue. Hurry up. Please.
Okay, thank you.
Okay.
Okay, next is 史玲红，
Okay.
你结束了是吧？
其实
他还没开始讲呢，学长。
我的天，那你赶紧。
Okay.
我以为你们聊了一会儿就聊结束了。
And this is my study. I study the visual data analysis in Python. Before we got the data, let's visualize our environment. And this picture is one topic of this course. And so on. And I study design trace Ludo. A design trace contains 3 types of the noodles: design noodle, opportunity noodle, and point. And this is a design trace code. I study by my one topic, and I predict the state. And this is a SWIM model. This is train score, and this is a test score. This is a decision function model in natural network. And this is the result. My report is all. Thank you, everyone.
Thank you very much. I suggest you could go a little bit faster to finish a general machine learning course. I encourage you that you're using English speaking online courses, very good. But I suggest you to go a little bit faster, and so that because you need to catch up to finish also reinforcement learning course, right? But of course, after you finish this, reinforcement learning course will be much easier rather than if you do not finish this before. So, but anyway, please hurry up, and then because I cannot give you a specific task or specific topic for the thesis before you finish your education. This is useless. So that's why I hope you could finish all. Okay. Okay. And don't forget about the content, about the plans. Okay. Thank you very much. Who is next?
Okay, thank you.
好的 ，Next is 史林红。
Hello, Professor. Can you see my screen?
Yes, we can see your screen.
Hello, everyone. Good afternoon. My name is Lin Hong. This is my report about learning progress of reinforcement learning. And there are 4 parts of my report. The first one is online courses, and the second one is algorithms. It's about Sasha and Sasha Lambda. The third one is neural networks and further plans. So I learned reinforcement learning from mofanpy.com, and there are what I have learned courses. And from these courses, I learned Q-learning, Sasha Lambda, and part of neural networks. And today I will show detailed algorithms about Sasha and Sasha Lambda. And this is formula for Sasha to update Q-table. Because Sasha also uses the Q-table, it's very similar to Q-learning, but Sasha is on policy and Q-learning is off policy, so they are different. My program is divided into 3 frames, including the environment of maze, algorithm implementation, and running programs. When writing the code of algorithm, I first need to define the parameters in the algorithm. Then I need to check whether the value in the Q-table is empty, and need to define the function of how the agent should act in next step. The last is the code to update the Q-table in the code implementation of the algorithm. The update of Q-table is particularly important So this picture is the code implementation of Sasha to update the Qtable. And Sasha update Qtable based on epsilon gradient instead of directly selecting the maximum value. So the Sasha algorithm is more conservative. In my program, I set alpha equal to 0.01 and gamma equal to 0.9 and epsilon gradient equal to 0.9. And the alpha means learning rate and the gamma means reward decay. First of all, I need to ask for the target value of Qtable, which is equal to the reward plus gamma multiplied by the next value in the Qtable. Then subject the practical value of the Qtable from the target value of the Qtable, multiply it by the alpha, and add the old value of the Qtable to get the new value. Through running, I found that the Sasha algorithm needs to run more times than the Q algorithm to get the reward. And the second one is Sasha Lambda. Sasha Lambda is a speed up methods of Sasha because Sasha use a single step update, but Sasha Lambda use lambda as a step termination value to update the Qtable that is different from single step update and run update. So there are two pictures are the code, the implementation of Sasha Lambda. This one and this one and this one. Because it's too long, so I need to use two slides. The algorithm of Sasha Lambda is very similar to Sasha, and the difference is that when updating the Qtable, it needs to be multiplied by a step termination. Well, before that, I need to create a table about step. It's the same as the Qtable. When I add a state to the Qtable, it also need to be added to this table. There are two ways to update the trace table. The first method is to add one when the agent through this step without capping. The second method is to change the value to 1 each time through this step. I chose to use the second method to write code. After I run the program, it was indeed much faster than the Sasha to get rewards. And there are courses a topic of neural networks because DeepQ networking reinforcement learning requires neural networks. So I chose to use TensorFlow to learning neural networks. The neural networks includes an input layer and an output layer and many hidden layers. Each neural in the neural networks contains an activation function. When the input layer receive information, some neurons will be activated. If the output result is incorrect, this activated neurons will become dull, and the other neurons will be activated, thereby changing the parameters and obtaining the correct output result. I only study a quarter of this course. The last part is the further plans. I will continue to learn neural networks, and when I finish learning neural networks, I will learn the DQN algorithm. That's all. Thank you, and happy birthday to Dr. Owenas. May gladness fill you every hour on this special day.
Oh, thank you very much. Thank you very much. Actually, the best present was your presentation. Thank you very much. It was very good.
Oh, sorry.
No problem. No problem.
Okay.
No problem. Actually, very good, very fast, very confident, and but you, maybe in future you could add some results for like Sun Tzu Shi, some results for some environments.
Okay.
For yeah, then almost perfect. And I think I understood everything that I need. So what do I need? I need to know when I can give you a specific thesis topic and a paper to read and start the discussion. That's the main key point that I need. So if I know that I'm ready and then you are ready, and so it's perfect.
Okay.
Thank you very much. I'm
Thank you
very
very much.
happy. Thank you very
Yeah,
much. I'm
thank you,
very
thank you.
happy
Mhm.
for your progress. Thank you.
Yeah.
Thank you.
Okay, thank you, Shilin Hong. Perfect presentation. And the next, our friend is Shilin Hong next.